Welcome to the first in our new 3D printing series. In this series we're going to take a look at 3D printing specifically as part of the remote control hobby, and there are those of us in the remote control hobby that are very familiar with electronics and how you put these kind of remote control systems together, but that now 3D printing is starting to be something that's interesting to us, and the cost of these machines has come down so much that it's actually an option for us to get hold of one and start to use it as part of our hobby. Now this is my new one that's just arrived, so thank you very much to banggood.com for sending this to me. I'll put a link in the description for this specific model that I'm going to use here. I will, once it's put together, be actually using this as part of the series, and we'll do a separate review video of this individual printer. But what I'm not doing here is saying that this is absolutely the one you should buy, because there's an awful lot of considerations when you're coming to buy your 3D printer, especially if it's the first one. In this series then we are going to spend time looking at the tips and tricks. We're going to try and demystify some of the language and technology that's all part of 3D printing. Just as when we came into remote control and started to learn all of these three-letter acronyms about ESCs, BECs, flight controllers, clean flight, base flight, multi-wheel, APM, all that stuff that we now just take for granted, there's a whole nother library and set of terminology and technology that you need to understand as part of 3D printing. So the aim of this is to try and teach some of that vocabulary to those of us with remote control, and it's going to assume that you're already reasonably familiar with remote control, because I'll use some of those as analogies to help understand some of the stuff that we're going to look at as part of the 3D printer series. We will be looking at tips and tricks. We'll be looking at how you make sure that you're getting the best possible prints out of your printer. Calibration is really key, and somebody jokingly told me when I first started playing with these things that once you thought you had your printer calibrated perfectly, do it another 3 times. And it absolutely is. Making sure that these devices are point perfect will give you the best possible print. Essentially what we're talking about here is a little robot that can move ahead in 3 dimensions and squirt liquid plastic out. The other point of these videos is to help those of you that are thinking of going to buy one make more of an informed choice. I am going to go through what those common things to think about are, and at the end of it I'm going to talk about my specific instance here and why I've ended up getting this particular model of printer that we've just seen in pieces on the table. What I don't want to do as part of this series is spend 4 or 5 episodes going into real detail in some of the software. Now there's loads of different software pieces that you need in order to make your 3D printer run, and that can sometimes appear daunting, but don't worry, we'll talk about that as part of the series, and I'm not going to then spend the following 3 or 4 episodes showing you how to create a right-angled bracket in SketchUp or 123D. I am going to show you the different options, talk about what I found using these kind of tools, show you a couple of things that I've kind of designed, and you'll get an idea for what the art of the possible looks like. I will try and talk as much as I can when I'm talking about the software about the free stuff. There are also chargeable things that you can buy, and the chargeable stuff is usually a better quality and gives you nicer results, but I'll mention those, but we'll try and use the free stuff wherever we can. I'm not going to spend tons of time doing comparisons and reviews of specific printers. We're going to look at this new one that I've got here. I've also used PrinterBots, which is what that thing is on the right hand side of this slide. They're a great basic starter device, and I've enjoyed using one of those, but the reason that I've got the one I've got now is there were a couple of limitations with that little baby PrinterBot, and hopefully this one will work better for some of the things that I want to do. So by the end of this little series, I'm not expecting anybody to walk away to being expert in all aspects of 3D printing. But what I'm hoping is, at the end of the series, it will give you enough information and enough context and vocabulary that you can go and then continue to look at all the 3D printing sites, white papers, videos, demos and other things, and they'll make a lot more sense. First thing we need to talk about then is the different types of 3D printers. Now there's loads of different types out there. There's ones that use lasers to cure a solution that's held in a vat underneath it, and loads of different stuff. The ones we are going to focus on exclusively in this series, because these are the ones that have now come down to the price point where we can all afford to get one, is something called a fused deposition model or Fused Deposition Material Printer, or FDM. Now, we'll talk about how they work in a second, but briefly, they melt a plastic filament and it precisely melts some onto the model that it's building up layer by layer, millimeter by millimeter, until it's actually printed it out. Sometimes that means that the little bed that the model is sat on moves left, right, but forwards and backwards, and the head moves up and down. Sometimes, like the printer that I've got, the bed stays completely still and it's actually the whole printer head that actually moves around. The way to think of this, if you haven't actually seen 3D printers working, is I always explain it, it's like a hot glue gun. So if you imagine you were going to build a box with a hot glue gun, what you do is you first of all draw a square in hot glue, then you draw the outside layer, then you wait for that to harden, then you draw another outside layer on top, and you build it up layer by layer until you eventually had a box. And that's exactly what a 3D printer is doing. It can move up, down, left, right, forwards and backwards, and it has a hot, heated element that then melts plastic and squeezes it out and actually lays it down. So how does that actually work? Well, what's actually happening is the model that you want to print is being sliced into lots of individual, almost 2D shapes. And those 2D shapes are then printed out one on top of the other by the printer, layer by layer, piece by piece, until eventually it's reconstructed that piece in 3 dimensions. If you imagine that you had something like an apple and you cut it very finely into like millimeter thick slices, you'll end up with a couple of hundred slices. And then what the 3D printer does is it's going to print each of those slices in turn until you have the apple again. So that is basically how the printer's working. You've probably watched those wonderful time-lapse videos on YouTube and you've seen them in action. The weird thing is when you actually start printing yourself, you'll find that you'll sit and watch for 20 minutes, half an hour, mesmerized as the printer starts to work. One, because you're not convinced it isn't going to mess up, and two, because it's actually such a cool thing to watch. But we'll go through how you make sure that that printer works every time, more or less. There are a couple of things that you need to think about when you're going to buy one of these things, and when I'm talking to people about considering 3D printers, this is what I would recommend. First thing, I would always try and go for a model that's already got good reviews and good support in the community. There's no point in going for the latest and greatest wacky machine that has some real innovation if you're not going to get support and you're going to struggle to use it effectively. So I would always say that you're looking for stuff with kind of 4.5 stars out there in the internet, and once you use that, if you have machines that only have 1 or 2 stars and has a decent number of reviews, then that's probably something you need to stay away from. The community is very, very good at spotting stuff that doesn't work very well. Sometimes it's because some of the devices are complicated to set up and get working consistently. Sometimes it's because it's badly designed. Do think about the size of the printer and the size of the print bed. Now, things like that little printer bot, which is on the right hand side, is actually bigger than you think, and the little bed underneath kind of moves around, and the actual print head on that whole assembly moves up and down. So you need quite a bit of distance around it as well. So have a think about the space that you've actually got to put this 3D printer in. Once you have a 3D printer set up, you don't really want to be moving it an awful lot, because every time you move it and knock it around, I would always probably be double checking my calibration. But once you do set it up, you want it to be able to move, and with pieces actually moving potentially outside of the base, then you need to make sure that you've got enough room around the outside. So just have a look, measure the kind of area that you have on the desk or in the area where you're going to set it up, and have that to hand when you're starting to look at printers. Also have a look at the size of the print bed. Now, the size of the print bed is just the physical size that the machine can squirt liquid plastic onto, and that dictates the maximum size of your print. So if you have a print bed that's 8 centimeters by 10 centimeters, then you're only really going to be able to print something that's 11 or 12 centimeters by kind of printing it diagonal across. Now, a lot of them can print quite high, and one of the reasons that I've chose mine is because it can, but you need to think about that as well. If you want to be printing quadcopter arms that are 30 centimeters long, then you know what, you're going to have to really look hard to find one with a print bed that's big enough. Have a think about the types of filament that you want supported. We'll talk about filament more in the next slide, but you'll hear a lot about PLA and others. Now, the reason for that is that some filaments like to work at hotter temperatures, and also potentially to have a heated print bed as well to help them stick. And if your device doesn't have that, so that simple printer bot at the right hand side doesn't have that, and this is one of the limitations that I found, it would print something called PLA wonderfully, and again we'll talk about the filaments in a second, but it would print it wonderfully. But when I wanted to try different things out, because it didn't have a heated print bed, I was struggling a little bit. Now, there are tips and tricks to try and get a device that's only designed for PLA to print other kinds of plastics, but you're basically trying to make the model do something that it wasn't necessarily designed to do. But in a lot of cases, you can make it do it. Do you have to think about the printer style? The ones, you can get them made out of acrylic, you can get them made out of metal, you can get them made out of balsa wood. Obviously things like the the balsa wood style that we actually got a picture of here are relatively fragile. The first two that I ever ordered both arrived slightly damaged, and that meant that they had to go back, and it delayed projects. It also means slightly less robust, and they're also more prone to warping slightly because the moisture in the air affects how the wood actually moves. So just be aware of that and think about it. There's also lots of different styles where rather than have one where it looks like an industrial robot, you have ones that, like in the other picture here, are like a cube where all the gubbins is actually inside. That's great because it means that apart from the print bed maybe extending out the back of the cube a little bit when it's moving around, you can pretty much guarantee that it's all going to be nice and neatly contained within that box. Or the third type is like the tripod kind, where you actually have three arms and it moves up and down inside almost a cylinder to print out. Lots of different styles. They all ultimately give you the same kind of result so long as you've got them set up properly. Do you ever think of the number of heads? Now, the heads that we've talked about are like the elements at the end of a hot glue gun. They basically get really hot. That we're talking about a couple of 100 degrees centigrade plus, and they will then melt the plastic. Now you can get different widths, and we'll talk about that later on. Everything from about 0.3 of a millimeter up to probably a millimeter plus for the big machines, but you want to have a think about how many of those you need. Now again, some of the ones that we're actually looking at, they've got pictures of here, are a single print head, and that's fine, and if you want to print everything in the same material, that's going to work great. Some of the more sophisticated ones will have multiple print heads, and the nice thing about that, it allows you to print in two materials. So you might have one material that's used to support the model if it has big overhangs, and that material can be soluble in things like hot water, so you can actually make the model that's really quite delicate and intricate with lots of support material, and then essentially wash it in warm water and wash that plastic away. If you have two printer heads, you can do those kinds of things. Don't have to use them all the time, but it's very handy to have that in case you do. Think about software support. Some of the printers that look very space age and quite boxy tends to be great and easy to use because the software that they use is quite locked down. So they try and restrict some of the open nature of it and really force you down to use particular products and software. Now that isn't a bad thing if you want an easy ride, but later on it might be that you want to try different things, and it can be harder then to try and get those printers working with other software and code. So open nature of the technology used can be important. When I was first buying the printers, I was going for ones that would give me the easiest ride and I wouldn't have to learn all the technology 1,000 times. Now I'm a little bit more confident and I'm quite happy to kind of try and make this work on my own because I've had a chance to do it. Think about how much support you've got. Think about how willing you are to have a play and set things up. There's some great support and forums out there, but for me right now, I would say being more open is more useful to me because I can actually try different things out. Last couple of things then, pre-built or kit form. Again, we can buy one like I've got it here, where it's basically a Meccano set and I've got to build it and set it up myself. This is something that I'm really looking forward to actually putting together, but then, you know, a bit masochistic at times. For some others, the idea of actually building something like that would leave them cold. And just like in remote control, there's no wrong answers. Some like to buy the planes ready to fly. Some like to make them out of foam. Some like to buy ready to fly quads. Some love the challenge of trying to build and make one fly beautifully themselves. Again, when I first started out, I wanted something that was pre-built, so if it didn't work, I could just send it back to the manufacturer. With ones like the one that we have now, I'm quite happy to kind of put it together. There's no right or wrong answer, it's what you feel confident with. And the last one I'd say, look for features like auto calibration. Because things like calibration and setup are so important, any machines that have a good feature where it will do some of that work for you, particularly if you're new to 3D printing, is worth its weight in gold. Read the reviews, check out the information, make sure that the auto calibration stuff actually works well, but those kind of features can really help in your first printer. We'll talk a little bit more about the kinds of filaments that are available, and these are the two most common that you're going to come across. There's loads of different filament types now, and they're available, as we say in the bottom, in 1.75 and 3 millimeters. 1.75 is really starting to become the default standard for home devices, and it comes on a spool typically in the way that you can see it here. And the two most popular are PLA, which is polylactic acid, and PLA is great because it doesn't need a heated print bed in order for it to stick. These are the ones that you tend to use the blue painter's tape for. Is a very common way that you'll print PLA, and the bed temperature, so long as it is kind of room temperature, it's fine, and it's a lower melting point as well, so the machine doesn't have to work as hard to melt the PLA to get it to bond effectively. So you'll find that a lot of the very entry-level printers will be PLA only because they won't have a heated print bed and they won't support the higher temperatures for the actual melting point as well. Now, PLA, in my experience, is a great versatile plastic. The things that I'm not a big fan of about PLA is that for RC it can be a little bit brittle. Once you've printed this up, if it takes a hard knock, it tends to snap. There isn't much give in it at all once it's been printed. So you have to potentially increase the walls of things that you're printing in PLA to give it a little bit more crash resistance. So things like the very first thing actually I printed in PLA was a little snap-on mount that allowed you to mount the Mobius camera and the FPV camera together as one individual item. And when I tried to push the mount around the Mobius lens, it just snapped, just gave way. It wouldn't put up with that kind of stress. It just completely delaminated and came apart. And that wasn't because the 3D print was bad, that's because in PLA it was a little bit too stiff and I was just snapping it. So another very common type of filament is actually ABS. I'm not going to try and pronounce what it actually is chemically. It requires a little bit more heat in order for it to melt it. You need a heated bed, heated print area for this to sit on. There are a couple of tips and tricks, and we'll talk about those. You can use something called ABS slurry to, which sounds wonderful, doesn't it? Which allows you to make sure that the print sticks, because it can tend to lift and not stick onto the bed if it isn't heated. And there are lots of other tricks and tips as well, even if you have a heated print area, to use things like hairspray to get it to stick. Now, we'll talk about these in much more detail later on, but I found that ABS is actually a slightly better plastic for remote control because it tends to be a little bit more rugged and can take knocks without just breaking. So I have gone for a printer with a heated bed because I want to be able to print ABS, and that was part of the reason why for me the simple printer bot was starting to become a bit of a limitation, because I was struggling to get it to print ABS well every time. So those are the two common ones. You'll come across loads of others like nylon and all kinds of funky ones later on, but those are the two that you'll probably start playing with when you first get into 3D printing. Very quickly, let's talk about the steps to actually get your model that you've got on your computer screen into reality, sat on the bed of the printer at the end of a couple of hours. Now, the first and easiest way to do it is to download the model that you're interested in. Loads of places, like for example thingiverse.com, have fantastic models that people have put time and effort into creating already, and those are available to download, usually as an STL file. And what you do is you download that STL file, which is just a set of geometry that describes the shape, and then you load that into some form of slicing software. And that bit of slicing software actually then takes that geometry and, just like we talked about with the apple, cuts it into lots of individual fine layers, one after the other. And the kind of slicing software that you'll come across regularly are things like Cura and Slicer. Once you've done that, then you can actually send that information to your 3D printer. Now, the stuff that actually goes to the 3D printer is something called G-code. Now, G-code has been used for numerically controlled devices and machinery for a very long time. So G-code is something that's pretty standard, very long in the tooth, and our 3D printers use exactly the same thing usually. So what we do here is we download the model, we download it as a .stl file, stick it into our slicer. The slicer is set up with all of the printer settings about how it's all going to work, and then we can get that to our 3D printer. The other option, of course, is that we actually design our own things, and there are a couple of options here as well. Now, the free ones that we'll probably have a little bit of a deeper look in later in the series are things like 123D and SketchUp. Both of those are free, downloadable, and you can have a go at them. I find that 123D is lovely for creating more organic, rounded shapes, and SketchUp is great for things that want very sharp angles. So here, for example, here's a little GPS mount I created in SketchUp. Here's a 10-degree Mobius mount that I created in 123D, and you can see there's a very different. You can get very similar results, but one is slightly better than the other at some things. And again, you can buy software that will do a better job than both, but again, we're talking about the free stuff mainly here. So now we know how we can either download a model or make it, export it and save it as an STL file, then you stick it in the slicing software. That then turns it into lots of individual slices, and then that goes to your 3D printer. That G-code is then used by the 3D printer to move the head around and to actually squirt the plastic out in the right places and put that plastic down in those individual layers that the slicers created. So let me talk about my individual printer. Now we've got a little bit of context, let me talk about my thought processes. I've kind of given a couple of hints already. So in terms of the reviews and commentary online, this is my second 3D printer that I've played with a lot. So this is one that I'm less bothered about that. I'm just looking for the basics to be covered and for it not to have any fundamental flaws. So that's okay. Also, the size of the printer and the size of the print bed. I don't have a lot of room, but the room that I do have, I can go tall, but I can't go wide. So I know that I need a reasonably big print bed, but one that has the smallest footprint that I can manage. I do want to support multiple filaments. We've talked about already. I want PLA, I want ABS, I want to be able to print nylon and anything I want. So having a heated bed is important to me, and also potentially having a couple of heads is going to come in handy as well, so I can print different materials in the same model. So I've gone for a tripod. So the style is it's going to have 3 rails up each side that the linkages are going to control to, and that's going to control the head. Software support for me, I don't want it as easy and as limited as things like the Printerbot were, so I've gone as open as possible, so I just want to use what's going to be easiest. And finally, I have gone for a kit. I'm going to put it together, and it does have a couple of auto calibration features, but I'm comfortable that with my vernier eyesight, as it used to be called in the engineering world, I can try and set this thing up and get it well working. So to go back to what we're looking at, this is the kind of printer that I'm in the process of building. So again, thanks to Banggood for sending this to me. It has a couple of holders on the top for my actual spools of material, and it's going to allow me to have a reasonable sized print bed, but not only that, I can also print quite tall as well. Now we'll talk later about lamination and stresses and strength in 3D prints, and there are some things that this is going to be great for and others that it won't be. So this is my printer that I'm going to be putting together and will use as part of the series. So hopefully now we've gone through this video, you understand a little bit about why I've chose this and why this is going to be the one that we're going to use this time. So hopefully for those of you that are new to 3D printing, that's helped. Please put your comments, suggestions and questions underneath this video, and we will try and make sure that as we develop this series, we're covering the stuff that you want to know. Thank you for taking the time to watch that video. There are lots of other videos on the channel and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching. Please like, subscribe and happy flying.